Hello, my name is Fatino Isfahani binti Ramli. For week 10, under our topic Diagnosing bias versus variance, for group H, to explain why the higher is the degree of polynomial, the higher is the error of the overfitting. In the condition where J train and J cross validation same, then they will be high. But when in the condition of variance of fitting, when the J train will be low and J cross validation will be greater than J train. So this is represented in the figure below for height bias underfitting and height variance overfitting. So as we can see here is represent for height bias and also height variance. So first now we plot for x, we plot degree of polynomial d, y we plot for error for both stranding and cross validation. So they will show two lines here to represent. This is to represent cross validation and cross training. So as we can see, this plot help us understand the error. We want to minimize both error. So how do we apply this for diagnostic? So what we can say is if cross validation error is high, we are either at the high or at the low of D. So what we can assume here is if D is too small, this probably corresponds to a high bias problem. But if D is too large, if D is too large, this probably corresponds to a high variance problem. So, as a conclusion, why the higher is the degree of polynomial, the higher is the cross validation error. Because for the high bias case, we find both cross validation and training error high. Maybe this doesn't fit training data well or doesn't generalize either. But For height variance, we find the cross-validation error is high, but training is low. Maybe this is because we suffer from overfitting. Training is low, cross-validation is high. Training set fits well, and but generalize poorly. So that's is that's all for me. Thank you.
Today I will explain why the higher is the degree of polynomial, the less error in the training error. This is because clearly for a given training set, when the degree is low, the hypothesis will underfit the data and there will be a high bias error. However, when the degree of the polynomial is high, then the fit will get better and better on the training set. We we run all the models with different polynomial degrees on the cross validation set. What we will observe is that when the degree of the polynomial is low, then the error will be high. This error will decrease as the degree of the polynomial increase, as we will tend to get a better fit. However, the error will again increase as higher degree polynomials that overfit the training set will be a poor fit for the cross validation set.
Hello, my name is Nur Fazliza Nazinda. I'm from Group H. I will explain on how the cost function with a large lambda value will result in value of theta being small, close to 0 at the beginning of the learning algorithm. Suppose we are fitting a very high order polynomial equation like the formula shown here, but to prevent overfitting, we are going to use regularization. A case of a very large value of the regularization parameter lambda, such as if the lambda were equal to 10,000, it is some huge value. In this case, all the parameter theta 1, 2, 3, and so on will be heavily penalized, and so we end up with most of these parameter value close to 0, and this hypothesis will be roughly of h of x just equal or approximately equal to the theta 0, and so more than the flat constant straight line, and this hypothesis has a high bias and badly underfit, and so this proves that this model is not a very good model for this data set.
So for linear regression with regularization model have three cases. So first case is a very large value of lambda. We assume that the lambda is 10,000. So the theta is near to 0. So the hypothesis is h theta x is equal to theta 0. So we'll get a straight line, and hypothesis is high bias, that is underfit, and this is not a very good model. So for the second case is a very small lambda. We assume that the lambda is 0. So the case is high order polynomial with regularization, and this is minimal without regular polynomial without regularization or minimal regularization overfitting setting. So the hypothesis is high variance. It means overfit. So the last is intermediate. It is neither large nor smaller value of lambda. So this is the reasonable fit for the model.